Hi everyone, this is 3.6 Compound Inequalities Day 1, and we're going to just basically go over what inequalities are, and on the next screencast, which is Day 2, we'll go over interval notation and how you should be writing your answers for those inequalities. So a compound inequality is when you have two distinct inequalities that are joined, and they're either going to be joined by the word and or by the word or. When you have two inequalities joined by the word and, you are saying that it meets both of those parameters. So the answer has to fall within both of those inequalities. So if you look at the first example, you have x is greater than, x is greater than or equal to 3, and then you have x is less than or equal to 7, and you are saying that your answer will be between both of those numbers. It'll be greater than or equal to 3 but less than or equal to 7. So it meets both parameters. So your answer has to fall between 3 and 7, which means it can be any number within those two numbers. With an or, you're saying it's either going to be one or it's going to be the other. So it's a little bit different than an and, because it's not going to have to meet both parameters. It just has to meet one. So here it has x is less than -2 or x is greater than or equal to 1. So either your answer is going to be on this part of the line, x is less than or equal to -2, sorry about that, or it's going to be on this, less than 2, or it's going to be on this side of the line, x is greater than or equal to 1. Okay, there is one more difference that we're going to learn. And that is when you graph your inequality. In the past, you have learned to do closed circles or open circles. What I want you to do from now on is, if you graph a closed circle, which means that it is included, your answer. So if you look on this one, x is greater than or equal to 3, right here, then you're saying that 3 is included. Instead of doing a closed circle like what they have here, I want you to do a bracket. And then if you look at this one over here, x is less than -2, you're saying that -2 is not included, which is why you have an open circle. Instead of doing that, I would like you to do a parentheses. So parentheses mean less than or greater than, and brackets mean less than or equal to or greater than or equal to. Another thing that you need to know is what inclusive and exclusive mean. Inclusive means that the numbers are included, so a greater than or equal to, less than or equal to, and exclusive means the numbers are not included, so greater than or less than. You're going to see these words more in word problems. You just need to remember what they mean. When you're solving an inequality with an and, since it meets two parameters, then a lot of times it's going to be written all together, because you're saying that the answer to this variable in here is going to fall between the two numbers on the outside. So what you're going to do is, we are going to split up into two inequalities. My first inequality is going to be all the way up until the next inequality sign. So -3 is less than or equal to m minus 4. My second inequality is going to start at the m here and go past the second inequality. So m minus 4 is less than -1. And then I solve them separately. So here I'm going to add 4, just like I would do in a regular inequality, and I get 1 is less than or equal to m. And here again I'm going to solve it, add 4, m is less than 3. So you can write it all together again, or you can leave them separate. It doesn't really matter, as long as you write the word and in between, because we need to know the difference between an and an or. When you graph this, if you were to graph them separately, it says m is greater than or equal to 1. So here's your 1. It's greater than or equal to, so it's going to go this way, or towards the right, if you're looking at it, and you're going to use a bracket because it's equal to, so it's going to shade this way. And then you have your 3, and it's less than 3, not included, so I'm going to do a parentheses, and less than goes this way. Notice how it's shaded in between, because your answer is an and, it should be in between the 1 and the 3. If you end up with an answer that is not shaded in between, then that means that it is going to be a no solution. That's a special case. An and should always be shaded in between. If it goes the opposite directions, it is a no solution. Try doing the example at the bottom. Make sure you pause so that you don't see the answer. Okay, so if you notice, the answer here is y is greater than 2/3 and y is less than 6. You need to be able to read an inequality from any direction. So even though the y is second in this problem, in the first part, you should be able to say y is greater than, because the open part is towards the y. So it's greater than 2/3, it's not included, so it's going to be a parentheses. It's less than 6, not included, so parentheses. Less than 6 is this way, greater than 2/3 is this way, so it's shading in between, which is what it should be for an and. So we know we did it correctly. Okay, here is an or. So an or is already split. It's not going to be written together because that's an and is written together, and or is not. So we just go ahead and we solve it. Okay, then we solve the other side. Remember your inequality rules. If you divide by a negative, you must flip the sign. So now we have t is less than negative 5/3 or t is greater than 1. We graph. Here is negative 5/3. Here is 1. It's greater than 1, so parentheses going this way. Shading this way because it's greater, and that's where the numbers are greater. It's less than 5/3, so parentheses because it's less than, and it goes this way because these are where the numbers are smaller. And so they're shading opposite from each other, which means that we did it correctly because it's an or. If an or goes towards each other, like an and, that's a special case, and therefore it means that you have an all real numbers. Every number on the line is shaded. It continues. It doesn't stop like an and does. If you have an or that goes in the same direction, then you only have one answer, whatever answer comes first. And you'll understand that when you see them on your homework. Okay, so go ahead and try the problem at the bottom. It is an or. You're going to pause the video so that you make sure that you have enough time to solve it. Okay, so as you can see, you end up with y is greater than 3 or y is less than or equal to negative 2. So when we graph on the negative 2, we want to make sure that we take into account that it's equal to, so bracket, and it's less than. It's greater than 3, so parentheses, and it's greater than. It's going in opposite directions, so we don't have a special case. Okay, here are two ands, and these have fractions. They're a little bit different, but you're going to solve it the same way. You're going to split it up. So you're going to do the first part first. So 15 is less than or equal to 20 plus 11, which is 31, plus k over 3. And then we do this part. So 31 plus k over 3 is less than or equal to 19. So we have our two equations, and then we solve each one. Just like you would solve a regular equation. To get rid of the fraction, I have to multiply by 3 on both sides. This cancels. I get 45 is less than or equal to 31 plus k. And same thing here. Multiply by 3 on both sides. 31 plus k is less than or equal to 57. Subtract 31 from both sides. So we end up with k is greater than or equal to 14, bracket, going this way, and it's less than or equal to 26, bracket, going this way. So they're shaded in between. Go ahead and try the example next to it. Okay, so if you look at this answer, you get x is greater than 15 over 4. I cleared the fractions because I didn't want to have the fractions and I get x is less than 17 over 2. In order for me to know where this goes on a number line, I have to change it to a mixed number. So 15 over 4 would be 3 3/4, and 17 over 2 would be 8 1/2. So I know that the 15 over 4 goes first, and the 17 over 2 goes second. So I just want to make sure that I know where it is on the number line. Okay, so x is greater than 15 over 4, parentheses, going this way, less than 17 over 2, parentheses, going this way. So it's shaded in between, which is what we needed to get with an and, so we did it correctly. Okay, so here you're writing a compound inequality from a graph. So if you notice, these have circles. So I'm just going to put in a little parentheses so I know that this is supposed to have a parentheses. And then I can do my compound inequalities. So this particular one is an and. I know it's an and because it's shaded in between the two numbers. So since it's in between these two numbers, I know it's going to be an and. And it is greater than -2. And less than 4. Both are open circles, so they're parentheses, which means the signs are going to be greater than and less than. Go ahead and try the next two. Take a second, pause the video, and see if you can get the answers to the next two. Here are the answers to the next two. So this one over here is an and, because it's between two numbers. You can also write it with the x in the middle, and the way that you do that is you put the smallest number first, the x in the middle, the bigger number second. And ands are always going to be less than signs. So it's less than 6, and if you look at the way that it is in this inequality, the open part is to the x, so it would be less than or equal to 3. Okay, and then here is an or, x is greater than, less than -2, or x is greater than or equal to 1.